Hello, can you hear me? Hello.
Hello.
Yeah. So have you finished the last few questions in the chapter on power of a
Yeah.
point?
Yeah.
Okay, what are your doubts?
I needed help on 13.34.
Before that, every question is done.
Yeah.
Okay. 13.34 says an equilateral triangle is inscribed in a circle. Points D and E are midpoints of AB and BC respectively. Is inscribed. D and E are midpoints of AB and BC, and F is the point where DE meets the circle. F is the point where DE meets the circle. We have to find the ratio of DE by EF. Okay, so we have a circle and an equilateral triangle. D and E are midpoints of AB and BC, and DE line meets the circle at F, let's say, and let's say this is G. We have to find DE by EF. Okay, so first of all, it's an equilateral triangle. So this point E, which is midpoint, if you join A to E, that will divide the triangle in 90 degrees and all. Basically, the line AE is not just the median, it is also the perpendicular bisector. So because it's an equilateral triangle,
Right.
the center of the circle will be somewhere here, and this is basically 90.
Yeah.
BE by EF. So fine. So let's look at some similar triangles. If you look at the line DE, the line DE is the line joining the midpoint. So DE is going to be half of AC.
Yeah.
And anyway, BD is half of AB, and BE is half of BC. So triangle BDE is going to be similar to triangle ABC because
Yeah.
all the sides here are half.
Right.
So we have similar triangles here and the big triangle. Um, So AD is equal to DP is equal to DE. All of these are equal. Okay, we know all of these lengths are equal DE, DP, AD, and now we can try to do power of point D. D is inside the circle, but still power of a point applies. So we can say it is equal to dB into dA and is also equal to dG into dF, right?
Right. Yeah.
dF is going to be dE plus EF, dE plus EF, and this side is dB and dA. dB and dA are all equal to dE. If you want to write, you can write it as dE square. So
Yeah.
this relation is there. Now we have to figure out what is dG. Uh, okay, so right, so the line DE was extended and meets the circle here, and it also meets the circle on this side.
Yeah.
And basically, what we can say is there is no difference between meeting the circle on this side or meeting the circle on this side. By symmetry, you should have this should be equal to this because the triangle is equilateral and it doesn't matter which side you meet the circle. Like you could have called this point as F and this point as G also.
Okay.
The triangle is equilateral. If you draw a line parallel to the midpoints, obviously both sides are same.
Right.
If you draw a circumcircle like this, it doesn't matter which side you meet, right?
Yeah.
So what we can say is by the symmetry of the problem, because the triangle is equilateral and this line is the midline joining two midpoints, both of these lengths have to be same, DG and EF.
Yeah.
If DG is equal to EF, we can write here EF into DE plus EF. And this is DE square. So we are getting EF into DE plus EF square. And this is DE square. And if you divide by EF square on both sides, you will get DE square by EF square is equal to DE by EF plus 1 because we are dividing by EF square on both sides.
Yeah.
Our job was to find this ratio. We can call this ratio x and you're getting equation x square is equal to x plus 1. So you'll get x square minus x minus 1 is 0 and you'll solve this equation using quadratic formula. And x is coming out to be 1 plus minus root over 5. 1 minus 4, so 5 by 2. And x cannot be greater than 1. dE by EF So we will take the smaller than 1 root and we will say that it will be 1 minus root 5 by 2. 1 second, let me think. No, 1 minus root 5 by 2 is going to be negative. So we'll not take the negative ratio. We'll take the ratio that is positive. Becomes 1 plus root 5 by 2 then. Basically, the point is that we have converted it into a quadratic equation. We are
Mm-hmm.
getting dE by EF whole square is equal to dE by EF plus 1.
Right.
And 1 minus root 5 by 2 will give us the negative root. We don't want negative roots. We are going to take the positive root then, and that is our answer. The
Yeah.
main idea here is if the equilateral triangle is like this and you have two midpoints, then obviously this line, and if you draw the circumcircle, there should be no difference between this length and this length because the triangle is symmetric inside the circle. If both the lengths are equal, then it's over because we can call this DE and GF and do power of a point with respect to D. That power of a point will be DG times this and this times this also.
Yeah.
From there, we get an equation which has the variable x as d by ef.
Right.
What is the next question?
13.36.
Okay. Chords AB and CD of circle O are perpendicular at point P. Given CP is 2, AP is 3, and PD is 6. Find the following OP and radius of the circle. So we have a circle and two chords which are perpendicular at point P. Two chords which are perpendicular at point P. Circle at center O and AB and CD. So AP is 3, PD, CP is 2. AP is 3, CP is 2. So CP, AP. This is 3, this is 2. And PD is 6. PD is 6. And you have to find OP and radius of the circle. Okay, so first of all, power of a point P will be PC times PD is equal to PA times PB. And you have 2 into 6 is equal to 3 into PB. So PB is equal to 4. We get this length as 4. And now this is 90 degree. We have to use the fact that this is 90 degree and think of what we can do with that. So if you okay, so we know this is 90. So we will have some results from Pythagoras theorem. If we make triangles here, we have to think of which triangle we should make. So if I drop a perpendicular from O to AB, I'm dropping a perpendicular from O, which is the center, to this line AB. That should be the midpoint of the chord, right? Perpendicular from the center to a chord will bisect the chord.
Right.
So if this point is called E, OE must bisect AB. Length of AB is clearly 3. Here AP and PB was 4, so 7. So this much is 3.5. And that means this much was 3.5 and this is 3, so this is half. So we have half here. And similarly, we can drop a perpendicular like this also from here to CD also, which will also be midpoint of that chord CD. So we now know that the length of CD chord is 8. So this must be 4. So this must be 2. So we have a situation where we have 2 here and half here. And now we can find this distance. By Pythagoras theorem, we'll find it as root over 2 square 4 plus 1 by 4. So root over 17 by 4, or half of root 17. That is coming as our length here. By Pythagoras theorem, we have made a rectangle by drawing perpendiculars from both from O to the AB as well as to CD.
Yeah.
Those perpendiculars will pass through the midpoints of those chords.
Mm-hmm.
Once we find this, now the thing is to find the radius, and radius will be easy now because we can join OD, that is our radius. We know that the length here is half of the chord. The chord had total length of 8, so this is 4, and this much is half. So
Mm-hmm.
obviously this length is going to be root over 16 plus 1 by 4. So root 65 by 2. That is the radius of the circle. The point is to realize that the perpendicular from center to any chord bisects the chord.
Yeah.
If you draw those two perpendiculars, because of power of a point, we already know all the lengths and the total length of each chord.
Mm-hmm.
After that, it is straightforward Pythagoras theorem.
Yeah.
How do you do question number 13.33 part C?
13.33. Okay. So for 13.33 part C, wait, do you want me to explain part A and B too, or no?
Part C.
Okay. So for part C, It says find PAEC over, find the area of PAEC over the area of BAE. So basically, for that one, through power of a point, we know that power of the point P, you know that PA times PB is going to be equal to PC times PD. And from the given values, we know that PA is 2, PB is going to be 2 plus 8, which is 10, and then PC is 4. So from that, we can plug that in and get that PD is going to be equal to 5. And then if PD is equal to 5, then CD is equal to 1. And you know that PAEC, if you draw a line connecting PE, you get two triangles, PAE and then PCE. So we can find the ratio of the areas of PAE to BAE, and you get that it's 1 over 16 because you squared the ratio of the side lengths. And
How do
then
you
you
know
get,
it is the 1 over 16?
because the side length of PA is 2 and the side length of BA is 8, so the side length ratios are 1 over 4. So then the area ratio must be 1 over 16 because it's squared.
Why? Just because side length is 1 over 4, area ratio is 1 over 16.
Oh, well, it's because they have like the same height, so they're similar.
What is the same height?
Like if you draw like a perpendicular from E, they have like the same height, PAE and BAE.
If they have the same height, how can the area ratio be square? Why will it not be just 4? Two triangles have the same height and side lengths are in proportion. You think the area ratio will be squared? If two triangles have the same height and the sides are in proportion 1 is to 4, what is the ratio of their areas?
Mm, 1 over 4.
So what are you
Because,
saying then?
oh, then I did it wrong. Okay, so then PAE over BAE would be 1/4. And then you can say the same thing for PEC over CDE. So their area ratio would be 4. Yeah, their area ratio would be 4. And then we know that PAE plus PEC is going to be PAEC. So we have to get the denominator to be BAE for both. So in like the previous part, in like part A, in part A, we found the ratio of ABE over CDE. And then what we can do, we can divide PEC over CDE by ABE over CDE because then the CDEs cancel out and we'll get that PEC over ABE is going to be equal to 1/4 because we got that ABE over CDE is going to be 64. So you get, sorry, not 1/4, 1 over 16. 1 over 16 because 4 over 64 is 1 over 16. And then you can add PAE and BAE together. Sorry, you can add PAE over BAE plus PEC over ABE together, and then you get 5 over 16. So what I did, like my way, I switched them up. I got that PAE over BAE is 1 over 16, and then PEC over ABE is 4. I switched them up when I was doing it.
How do you do 13.35?
35. For 13.35, It says segment IF is tangent to the circle at point I as shown in the diagram. We are given that IF is 21 root 2, IO is 20, and then ON is 12, RF is 18, and OR is greater than GO. And it's asking us to find OR. Okay, so through power of the point F, we know that IF squared is going to be equal to FR times FG. So you get that 21 root 2 squared is equal to 18 times 18 plus OR plus GO. If we expand that, we get that 882 is equal to 324 plus 18 OR plus 18 GO. And then from that, if we simplify it, we get that 31 is equal to OR plus GO. And then if we look at power of the point O, we get that IO times ON is going to be equal to GO times RO. So you get that 20 times 12 or 240 is going to be equal to OR times GO. And what you can do, you can plug in. So from our earlier part where you get that 31 is equal to OR plus GO, if you solve for GO, you get that GO is just 31 minus OR. So you can plug that in to 240 is equal to OR times GO to get that 240 is equal to OR times 31 minus OR. And then if you solve for that, you just get a quadratic. So you get that quadratic as OR squared minus 31 OR plus 240. And then if you solve for that, you get that OR could either be 15 or 16. But because we know that OR is greater than GO, it has to be the greater one. So OR is equal to 16.
Okay, solve this problem. You have to find the possible values of angle ADC.
What does concyclic mean?
They are the points of a cyclic quadrilateral.
Okay.
The points B, D, M, N are the vertices of a cyclic quadrilateral.
Okay.
What are you doing?
Mm, I'm trying to see if there's any way we could find like, because for angles, for cyclic quadrilaterals, all we know is that like opposite angles add up to 180. So, but that doesn't really help us here
Why doesn't it help us?
because we don't know any angle measures. Like we can say that angle ABC plus ADC is 180, and then we could say like angle MBN plus MDC is also 180, but like I don't know how to form a relation between them.
If I need an angle ADC, can you find angle ABC?
It's 180 minus ADC.
What do you need to find in the question?
We need to find ADC.
So you need to find the value of angle ABC then.
Right.
If you can find the value of angle ABC, you will get ADC.
Yeah.
So what is special about these triangle? How can you find this angle? Where are you using the other information given in the question?
M is the midpoint and N is the midpoint. Well, that means BM is the median, so oh, that means that AC is the diameter. Oh, then if AC is the diameter, that means angle.
Why is
Uh,
AC the diameter?
oh wait, never mind. It's not the diameter. What am I saying? Sorry. Um, hmm. Well, if they're equal, that means BM is a median. So then,
What is angle BDC?
BDC,
What is it equal to?
BDC is equal to BAC.
What else is it equal to?
It's also equal to mm,
Why was BDC equal to BAC?
because they're subtending the same arc
On which circle?
on circle ABCD.
Is there any other cyclic quadrilateral?
Uh, yeah, there's
So can you get another equality?
you can get that angle BD is equal to angle BDN.
That is obvious. What else can we say? What is BDN equal to?
BDN is equal to
In cyclic quadrilateral BMDN, you cannot find what is another angle equal to BDN.
would it be BMN?
Why is it taking so long to say this? Isn't it obvious?
Yeah.
This is not a cyclic quadrilateral BMDN. We have equal angles. This angle is equal to this angle is equal to this angle.
Yeah.
What is special about MN line?
MN is a diagonal. No.
You have to find something special about line MN.
Yeah.
What is special about points M and N?
They're midpoints. So then MN is a mid segment of ACK.
What is special about line MN?
It's half of AK.
And
And
by
and
midpoint theorem, what?
it's parallel
To what?
to AK.
So what can you tell from parallel lines? Now what angles will be same?
BMN is going to be equal to MNC.
Which lines are parallel?
Oh, wait, sorry. AK and MN. So then KAM is going to be equal to MNC.
Again, that's wrong.
Wait. Sorry, KAM is going to be equal to NMC, and AKN is going to be equal to MNC, like corresponding angles.
First of all, we know that this angle will be equal to this angle.
Right.
What else do we know? What is this angle going to be equal to?
That angle is going to be equal to
ABM is equal to what? If lines AB is parallel to MN.
It's going to be equal to BMN.
Basically, we are getting all of these angles are equal. This angle is equal to this angle is equal to this angle is equal to this angle.
Yeah,
Why?
because they're parallel.
We already have these angles are equal.
Yeah,
BMN is supposed to be same as BAC
right.
is supposed to be same as BDC. Now we also have they are equal to angle ABM and also equal to angle CMN.
Right.
So what do we know now? What extra things do we know now? We have found out 5 angles which are same. We should be able to say some stuff now. Especially because 2 of the angles are in the same triangle.
We can say that
Can you see in the figure that 2 of the angles are in the same triangle? You cannot see that this angle is equal to this angle in the same triangle. Angle,
oh, right.
what are you looking at?
No, I was looking at the ones we wrote down and I didn't see any of those in the same triangle, so I was confused for a sec.
You look at the angles by the letters or you should look at it in the diagram.
In the diagram.
So how are you not seeing that there are 2 angles in the same triangle here?
Yeah. BAM and ABM. So that tells us that it's isosceles.
So what now?
Oh, so BM is equal to AM is equal to MC.
Then what?
Mm, and then, wait, can we say that BAC, sorry, could we say that triangle ABC would be right because, like a right triangle, because the circumcircle through ABC and then the mid, wait, no, we can't say that, never mind. Because we don't know that N is the center. Never mind. Um,
What can you conclude from BM is equal to AM is equal to MC?
we can say that
Is there a something special about point M now?
Would we can say that it's the center,
Center of what?
the circle,
How do you know that?
because it's like equidistant from those 3 points, which makes it a center.
M is circumcenter. So
Mm.
is M also the midpoint of AC?
Yes,
So when is circumcenter going to be midpoint of a side?
when it's a right triangle.
So which angle is 90 degree?
B, angle ABC.
So what is angle ADC?
So then angle ADC has to be 90.
That's the solution. You have to notice that MN is parallel to AK. You have to notice that this is cyclic. So these angles are all equal. And if these angles are equal, this triangle becomes isosceles. And all of these are equal, which means M is the center, which means this angle is 90, which means this
Yeah.
angle is 90.
Mm-hmm.
But you are supposed to be able to do it yourself. Next class will be starting number theory. Tuesday's
Okay.
class will be on number theory and Thursday's class will be on geometry. So for geometry, you have to homework is read the next chapter 30 chapter 14 on 3D geometry and
Mm-hmm.
do as much as you can there.
Okay.
So I expect you to finish at least the theory and start the exercises and stuff for the
Yep.
next
Okay.
chapter.
Okay.
Tuesday's class will start with number theory.
Mm-hmm.
Okay, fine. That's all for now.
Right. Thank you. Bye.